So this is AP Statistics question 2006, Test B, and this is question 3. This is the golf ball question that you had on Friday when we had the substitute. Okay, so we're going to take a look at this question first. We've got some golf balls that when it's hit by a mechanical device with a 10-degree angle of launch, backspin of 42, yada 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 yada, and a ball velocity and so on, the distance the ball travels may not exceed 291.2 yards. Okay? So people who make golf balls want to make them so that they'll travel as close to that without exceeding that distance, kind of like Price is Right. You can't go over the price. Okay? So this manufacturer has determined that the distances traveled for the balls it produces are normally distributed with a standard deviation of 2.8. So I'm going to put in here sigma's 2.8 yards. Okay? Manufacturer has a new process that allows it to set the mean distance the ball will travel. Okay, so there's a dial on the machine that's the mean distance. If the manufacturer sets the mean distance to be 288, what's the probability that a ball picked at random will travel too far? Okay, that one's easy. Here's the distribution of how far a ball selected at random will travel. Normal 288, sigma is equal to 2.8, and if it travels too far, it's going to travel greater than 291.2. So what's the probability that x is greater than 291.2? And I really don't need the equals there. And it doesn't change the probability anyway. Okay, so I'll get my calculator out, and I'll go ahead, I'll make that bigger so you can see it, and I'll go ahead and do normal CDF of 291.2, big number, 288 is the mean, standard deviation is 2.8, and the probability is 0.1265. So let's write that, 0.1265. That's the probability, and this is the answer to part A. So for part B, let's assume the mean distance traveled is 288 yards. So this is truly the mean that they set. So mu is equal to 288. Okay? And 5 golf balls are independently tested. All right, so now we're taking a sample of 5 golf balls. What is the probability that at least one of the 5 balls will exceed the maximum distance? So what's the probability that x is greater than or equal to 1, where x is the number of balls that go more than 291.2 yards? Okay, so what we have here is a binomial situation, okay? Because we've got success or failure. Success, the ball goes greater than 291.2 yards. We have a fixed number of balls, 5, and the probability of being successful is from the last part of the question, which is right here, 0.1265. So let me write over here that the probability of success is 0.1265. And so we're looking at a binomial situation, probability x is greater than or equal to 1, okay? And remember what I told you to do, right? Do this. We're looking for these probabilities, okay? CDF functions can't do this, but you can look at 0 and subtract it from 1 to find what's left over. So 1 minus the probability that x is equal to 0, and then we can use our binomial function. I'll just do it. I'm not going to write it down this time. You guys are good enough at it. Okay, so here we're going to look at binom PDF. So right up here, choice A. N is 5. Probability of success is 0.1265. And we're looking for none of them being successful, none of them traveling more than 291.2 yards. And the probability is 0.5085. Okay, so I'll go ahead and write that down here. Equals 0.5085. Notice I didn't write the calculator speak down. All right, this is the work. That's what you want to show for the work. Okay? Okay, now question C is the hardest one. If the manufacturer wants to be 99% certain, so 99% certain that the randomly selected ball will not exceed the maximum distance, what's the largest mean that can be used in the process? Okay, so what we've got now is this situation. We have an unknown mean, mu. We want the maximum distance, 291.2, to be there, and we only want 1% of the balls to exceed that distance. So 99% of the balls are not going to exceed this distance. So we need to find the mu that gives us a 99% area here, or left tail from 291.2. In a probability statement, that would look like this. The probability that a randomly selected ball travels 291.2 yards or less has to equal 0.99. What does mu have to be? Okay, and this is where we have to do some standardization, because this is working the problem backwards, and we can't do this with the calculator. So what I'm going to do is standardize. 291.2 minus mu over sigma equals 0.99. Okay, and I want to slide this screen down just a little bit because I'm going to run out of room if I don't. So I'll put that down like that. Okay, we can still see our picture. This term right here is a z-score. 291.2 minus the unknown mean over the standard deviation. And what was the standard deviation again? I forgot. 2.8. So we'll put that over 2.8 equals 0.99. Okay. From the normal table, a z-score that gets you a left tail area of 0.99 ends up being, oops, thought I was going to be able to pull that off the top of my head, but I can't. So I'm going to go ahead and compute it. Inverse norm of 0.99 with a mean of 0 and a standard deviation of 1, which is what a z-score is 2.326. Okay, so we'll use 2.326. The probability that z is less than 2.326 is equal to 0.99. Okay, notice these statements. They're basically identical. We have z here. We have the 99% left tail area there. If those are all equal, then this has to be equal. And so we have a mathematical equation now, 291.2 minus mu over 2.8 is equal to 2.326. And so we do some algebra, and we get 291.2 minus 2.326 times 2.8 equals mu. Okay, and then if I figure that out with the calculator, I get 291.2 minus 2.326 times 2.8, like that. And so I find out that mu has to be 284.6872. So mu is 284.6872. And that's the value of mu that will ensure that only 1% of the balls ends up being illegal by traveling too far a distance. So there's your question.